All right, so these are a few more momentum problems. Now these are more not so much conservation of momentum as the interaction between momentum and force, and then also impulse. And so there's a couple of equations you got to be aware of for that. So we know that for momentum, the equation is momentum is equal to mass times velocity. We know that force, the equation is mass times acceleration. So momentum, or force rather, the unit is in newtons, but velocity, the unit is newtons times seconds. So that means that my force, I can get force by just simply taking force times seconds, right? So force will equal, all right, let me put it this way. P is equal to force times seconds, right? Newtons times seconds. And then when we're talking about impulse, impulse is really just the change in momentum. So it really is the same thing. This is also equal to impulse as far as newtons per second, but impulse, you're looking for the change there. So I have three different questions here. We have an impulse question, and then we have a couple of questions that involve force and momentum. So let's start with this first one. I have a 40 kilogram mass. It's moving across a horizontal surface at 5 meters per second. And we want to know, what is the magnitude of the net force required to bring the mass to a stop in 8 seconds? And so this is telling us that we have some sort of momentum. We want to figure out what momentum essentially is needed to stop it. And when I'm looking at this first one, I have since I have 40 kilograms, and it's moving at 5 meters per second, we know that this is going to be equal to 80, wait, no, I'm completely screwing this one up, 5 times 40, 200 rather, boy, newtons per second, right? Or newtons times seconds. Okay, and then we want to know, what is the magnitude of the net force required to bring this mass to a stop in 4 seconds? Well, I need my net force to turn that into momentum, and I'm going to use this equation right here where momentum is equal to force times seconds. And so I can just say, well, I'm just going to take 200 newtons seconds, and I'm going to set that equal to my force times my 8 seconds. Okay, and if you look at that, that gets rid of my seconds, and I'm left with my force. So that's easy enough, right? 25 newtons. So my answer is 25 newtons, okay? And that's, just make sure you just remember this little quick easy formula here, right? Okay, second one, I have a 0.15 kilogram baseball. It's moving at 20 meters per second and is stopped by the catcher in 0.010 seconds. The average force stopping the ball is, and so if I have 0.15 kilograms, and it's being multiplied by 20 meters seconds to the -1, that's going to equal 20 times 0.15. So that gives me a momentum of 3 newtons seconds, right? Well, I want to figure out what the average force is, and force is in newtons. That's what it's telling us right here. So all I have to do is figure out how to get rid of that seconds there, and so I get rid of it by dividing out seconds. So 3 newtons seconds. Let me redo this. 3 newtons times seconds divided by the 0.010 seconds gives me an answer of 300 newtons. Now they've used scientific notation, so we're going to have 3 times 10 to the 2, right here. So number 4 would be our answer. So 300 newtons, or 3 times 10 to the 2 newtons. Okay. All right, so let's do a couple more of these force, momentum, impulse problems. Keeping in mind that our equation is momentum is mass times velocity, which is newtons seconds. Force is equal to mass times acceleration, which is newtons. And then we can use this equation where momentum can also be calculated out by force times seconds, which is equal to newtons times seconds, right? Simple enough. So in this question, I have a 60 kilogram student jumps down from a laboratory counter. At the instant he lands on the floor, his speed is 3 meters per second. If the student stops in 0.2 seconds, what's the average force of the student on the, what's the average force of the floor on the student? So we could also say that force is equal to momentum divided by seconds, right? Because we know that what I want for force is newtons, and so if I take newtons per second divided by seconds, I get force. So let's do that. Let's take 60 kilograms, and we'll multiply that by 3 meters per second, and then we'll divide that by the seconds, 0.2, and this equals 900 newtons, which is the same thing as 9 times 10 to the 2 newtons there. Okay. A 2 kilogram cart, laboratory cart, is sliding across a horizontal frictionless surface at a constant velocity of 4.0 meters per second east. Okay, let me draw a little picture of that. I have this cart, it's going along this way, it's 2 kilograms, and is moving at 4 meters per second in the easterly direction. What will be the cart's velocity after a 6 Newton force, a 6 Newton westward force acts on it for 2 seconds? So in this case, what I really want to do is do sort of a conservation of momentum. And so I want to know my momentum at the start and then what's being applied to it. And so I'm going to turn this force into momentum. And to do that, remember that all I have to do to get that is I just take my force times seconds. And so if I take force times seconds, I have 6 newtons, and it's being multiplied by 2 seconds. So this is going to equal 12 newtons times seconds. And then this one, 2 kilogram cart, this is equal to 8 newtons times seconds. So essentially what is happening is I have a force going this way at 8 newtons seconds, but then I have the momentum going that way, but in this direction, because of the force and the time, I have 12 newtons seconds. Okay, so when you look at that, you realize, okay, it's pretty obvious what's going to happen. I'm going to have a net momentum in the going to the left of 4 meters per second, or I should say 4 newtons per second. Okay, and so when I want to find out what will be the cart's velocity, I could say, well, if my momentum is 4 newtons second, and it's going in this direction, which would be to the west, I could even say it's negative in this case, and we know that anything going in the left direction is negative, and this is equal to your mass, which is 2.0 kilograms, and then our unknown velocity, 4 divided by 2 is negative 2 meters per second. And that means that it's going 2 meters per second to the west. Okay?